Hi, this is Mrs. LaBarbara. This is AP Physics Mechanics C. Today we're going to talk about an example that has conservation of energy, conservation momentum, and projectile motion. So here it goes. A chunk of clay of mass 0.2 kilograms is thrown from the ground with the initial speed 12 meters per second at an angle 30 degrees with the horizontal as shown. At the top of its trajectory, the clay strikes a small block of mass 2.3 kilograms suspended from 3-meter-long string. The clay sticks to the block, which then swings freely, neglect air resistance. Part A, calculate horizontal distance d between the launching point of the clay and the point on the floor directly above the initial position, as shown in the diagram. So this distance is actually half of the range. So if you know the range equation, remember that you can use that and just half it. If you don't, you can always start from d equals VIX times t. We can figure out VIX, use initial velocity times cosine theta. The t, the time to go to the highest point, we can also find out because we know initial vertical velocity, we also know vertical acceleration, we also know at the highest point its vertical velocity equals to 0. So from those parameters, you can find t. So here is VIX, VI cosine theta. Substitute the numbers in. Here is the equation how to find the t up, the t at the highest point. Substitute all the numbers in. So here is t, here is your VI, that's how you find the d, 6.36 meters. Part B, calculate speed of the block clay system immediately after the collision with the clay. See, whenever you see a collision, that's a conservation of mostly momentum, right? So before the clay was moving in the horizontal direction after the clay stick to the block. So P before equals to P after. P before is just mass of the clay times velocity of the clay. Remember, this is at the highest point, so velocity of the clay is the horizontal speed or the horizontal velocity of the clay, initial horizontal velocity. And after, two of them move together. So VC just equals VIX, that's 10.4. Substitute all the mass, which is given 0.2 kilograms and 2.3, so we can solve for V. So V equals to 0.83 meters per second. That's the clay and the block is moving after the collision. Part C, calculate the angle through which the block clay system will rise before it comes momentarily to rest. So over here, you have a speed, then this is going to swing all the way up. So what is the angle when this block stops? So let's draw a picture over here. Here is the block. Here is at the highest point. And what is this angle? So during this time, the energy is conserved. The reason why the energy is conserved is because the only force doing work is gravity. Tension does not do any work because tension is perpendicular to the displacement. So here is position 1, here is position 2. We know E1 equals to E2. At E1, all the energy is kinetic. At position 2, all the energy is potential. So we have to find H. Take a look at this diagram. Here is a right triangle. H equals to actually L minus this part. This part is L times cosine theta. Substitute in. You can figure out cosine theta. Divide both sides by g and subtract both sides by 1/2 v squared. Plus add a cosine theta on both sides. So you will have cosine theta equals to 1 minus v squared over 2g. You know v, 0.83 meters per second. You know g is 9.8, and that's how you can find theta. Make sure you use inverse this number to get the angle, which is 8.8 degrees. Next part, calculate time between when the block is struck and when it first returns to its original position. So after this block is being struck, it's going to swing back and forth. So it's going to come all the way here, then comes back, then goes to the left and come back. We call that time a period. From original and comes back, then that's one cycle, the time of one cycle. So this time going over here to the right, all the way to the top of the right and coming down, that's half of a period. For the simple pendulum, the period is 2 pi times square root of L over G. We know the length, we know G, so simply substitute everything in. You should have time is 1.7 seconds. That's half of the period. So the total period would be 3.4 seconds. Part E, the procedure is repeated with a chunk of clay of greater mass. Indicate whether the new angle will be greater than, less than, or the same as determined in Part C. Is that bigger than 8.8 degrees, less than, or the same? Justify your answer. Think about it. If the clay is bigger, you're still launching with the same speed. That means this one will have a bigger momentum when it comes in. That bigger momentum, when it collides with the block, the clay block system will have a greater kinetic energy. As a result, this will rise higher, so the angle would be higher. The new angle is greater because the increase the mass of the clay will increase the momentum of the clay. As a result, the block clay system will have a kinetic energy after the collision, and this increased kinetic energy will result in greater height, hence greater angle. That's it. I hope it helps. Thanks for watching. See you next time.